So in this video I'm gonna show my interfaces and interactivity project and how it works, and especially what went wrong with the prototyping and the assembly. As said in the proposal, the project consisted of a modded original DMG Game Boy from 1989 in order to create a MIDI instrument, because it's the Game Boy is already used as an instrument in the chiptune scene, musical scene, but I always thought that these controls were kind of limiting for the potential that this machine could reveal. Unfortunately, the project didn't go well, but I was able to save a good part of it. So the electrical system is composed of a bottom part and upper part. In the upper part we have the upper motherboard of the Game Boy, these keypad 4x4 matrices by Adafruit, OLED screen, in this design a rotary encoder and only a MIDI output. In the original design it was meant to have MIDI output, an external MIDI input, 3 states switch to switch between the first bank of the step sequencer, the second bank of the step sequencer, and an options bank to send MIDI control change commands. But unfortunately I wasn't able to implement it in the end. And a volume knob, which is right here at the moment, and a jack plug 3.5, which is also here, stereo jack plug, and a button, a play stop button, which I moved here because I had to rewire the circuit. Moving to the bottom part, we can see that this is the bottom DMG motherboard, and here we have a LiPo battery to make the whole system portable, the power circuit, which starts from the battery. So the battery plugs in here, and then this is the voltage regulator to turn down the voltage, because all the system runs basically on 6 volts and this battery is 7.4. And the voltage regulator is also connected to a switch, to a power switch down here. And this board in the middle is the audio amplifier, which for space reasons I had to put here. And in the end, these two Arduino boards, an Arduino Nano revision 3 and an Arduino Nano 33 BLE, which were the problem and what went wrong with the system. So basically the system was supposed to be connected this way. The bottom part of the bottom part and the upper part of the Game Boy motherboard are connected only by this ribbon cable, which shares the pin of the cartridge, of the Game Boy cartridge, and the pins of the Game Boy screen. The bottom motherboard was connected through the pins on the link cable, which are these one. At the moment they are disconnected. Was connected to this Arduino, which had a third-party code not written by me, from Timothy Lamb. It was a Game Boy mod to give the Game Boy MIDI functionality. Then this Arduino had a MIDI in and a MIDI out circuits. The MIDI in was connected to a two-state switch, and the switch was here in order to be able to switch between an external MIDI input and the MIDI input of the sequencer, and then a MIDI output to program a pattern on the Game Boy and send it out to an external instrument. The other Arduino board had my code, and it was what ran the screen, the keypad, and all this control, and it was supposed to send MIDI messages from here to here to be converted into a language that the Game Boy could understand, which is basically a normal serial communication. What went wrong? Well, when I ended the prototyping phase, so I started prototyping step by step, and I have videos of the Game Boy receiving MIDI messages. Of all the mods I did to the Game Boy. But when it was time to wrap up everything and put everything together and finalize, bad joint. No, actually I forgot to cut a resistor leg, which I guess made a big short circuit that burned this board, probably either this one or the opto isolator down here, this one, or this diode, and the audio amplifier. So in the end I had only one Arduino 33BLE, and there was no time to buy another one and re-upload the sketch to fix the situation. Apart from these things though, everything else worked, but I can't put the whole system together. And also I can't reproduce audio from the Game Boy out of the speakers, but I'm able to send audio out of the jack, because this jack bypasses the audio amplifier, while the audio amplifier was connected to this speaker and this speaker down here. So fast cut to put everything in place. Obviously underneath this case, and the case was all 3D printed, and also it misses the sides because I had no time to print them, because I had to fix that main problem. And on the back you can see the slot for the cartridge, which can be put down here. And this is a flash custom cartridge that permits you to upload custom ROMs to the Game Boy. So trying to close it to show that the Game Boy is working and that the mods are working. Okay, connected. Okay, so I connected the ribbon cable of the motherboard, the upper one to the lower one, and I connected a pair of headphones to the jack. If you can see it. Okay, so that you can appreciate the sound coming out. So if I turn on the switch here and turn on the Game Boy, so as you can see, there's a backlight screen, which the Game Boy hasn't, and the audio apart from the amplifier is working, and everything else is working. The only problem right now is the communication, but I think I could fix it in the future with all the parts. So, because the Arduino 33BLE was faulty, was burned, and to try to fix the situation and be able to continue coding my software, I had to use this Arduino Mega 2560, which is quite a different board, so I had a tough time recoding most of my program to fit this board without obviously the rewiring of the electrical circuit. I used the audio output that was supposed to be on this board to be able to send out MIDI messages and demonstrate that the concept and the state of the art of my project is feasible. It's only a matter of prototyping and having a bit more time to sort it. So, turning on the system, we have this boot up screen. I decided to call it Volca Boy Plan B, just to add a bit of humor to the situation. And then we have this user interface, which contains the software version 0.1, the channels from 1 to 4, like the Game Boy, and then a glyph representing the step selected, and another glyph represented the note. So how the system works? Basically, there are 3 states in which these keypads can be, which are idle, like right now, enabled, which is with one press of the keypad, or armed, which is, and as you can see, as soon as you click, let's say for example 6 step first channel, there the steps lights up. If I decide to light up the third step, or the third channel, okay, coming back to light, third channel 8th step, see it lights up. So this is the enable state. The armed state happens when you enable a node, so you select a step and a channel. So let's say for example channel 1, step 2, and you, with the knob, you select which MIDI note to play. I unfortunately had no time to implement the name of the notes, so I have to find out like this. And as soon as you click this rotary encoder, it selects the note, stores that in memory, and turned the key to the armed state, which is this blue. As you can see now, this one is blue, but if I, for example, click, another one is light blue. So for example, if I selected this one, which is third channel 8, unselected. One problem that I should sort is that the counter of the rotary encoder doesn't start from the same point. I mean, it does start from the same point and not from a default like 0. So if I select, like for example this note, I have to start from 77, which is quite daunting, especially if you have to keep going back and forth to select all the notes. So let's turn down those ones. Okay, so when the keys are disabled, nothing is playing. To be sending out MIDI messages, the system has to be the key, a random key, has to be enabled and armed. What does this mean? Okay, now nothing's connected, but afterwards I'll show you with a Korg Volca bass connected. So if I press play now, you can see that the cursor is going, and on the screen you have which step is highlighting and that play symbol. If I stop, everything disappears, and as soon as I click at the bottom to enable it, the cursor disappears. Whenever I press play, there's no pause button, it starts from 1. And if I only, as you can see, if, let's say now I activate some notes and I armed some other notes. Okay, now you can see that if I press play, the notes that were enabled but not highlighted, not armed, are disappearing. That's because there isn't a note selected on those keys. Only the notes that were enabled and armed can play. So this is supposed to work with a Game Boy, so 4 channels, pulse 1, pulse 2, wave, noise. Unfortunately, to show today this video, the only instrument capable of receiving MIDI messages is this Korg Volca bass, which can receive only 1 channel at a time. But I can change the channels on the Volca bass to show you that all these can play. Obviously I don't remember if I specified, but each row corresponds to 1 channel, so channel 1, channel 2, 3 and 4. So now connecting the cable on the system. Okay, so cable is connected. I can turn on the Korg Volca and try to make a fast pattern on this one. Obviously for now on channel 1. Wrong. I'm looking at notes about the note to play, because obviously I can't remember the MIDI code. So for example, now I put in the Stranger Things theme. And this one is sending out the Stranger Things theme to the Korg Volca, which obviously can be tweaked. Unfortunately, another problem that I wasn't able to address in this little period of time, was the BPM selection that was supposed to be into the option bank, which right now isn't here because I hadn't time to connect the 3-pole switch to select bank A, bank B and options. So right now it can only play the bank A, but the code is ready to accept, as you see in the Arduino sketch, is ready to accept the switch and to switch the bank. I can edit the pattern while it's going, so like for example turning off and also if I want I can, but I have to be fast and I haven't considered this eventuality, like for example I have to wait, because if the cursor passes the note while it's enabled and not armed, it will delete it. So and that's for channel 1. So now if I change the Korg Volca channel, which is done by pressing the memory button and turning on, you can see channel 1 . If I say channel 3 step rec, it should change the channel. So now if I play this pattern, which is only on channel 1, it shouldn't be playing on the Korg Volca, and that is right. But if I go to channel 3 and I select a note, you can hear that it's playing. Okay. If I change again, let's see. Memory, channel 4 step rec. Okay, now it's on step 4, so no sound, but if I activate a couple of notes at random, and press play, it plays. So I am almost certain that in the situation of having the Game Boy connected, I would have been able to play the 4 channels on the Game Boy. It's only that, again, unfortunately, these things are quite risky and sometimes things go wrong. So this was my project, the Volca Boy sequencer plan B.